So my name is Zack Bloom. I work at a company called CloudFlare. If you use the internet, you probably have used CloudFlare. You probably use CloudFlare today because we sit in front of about 10 million websites. And so roughly 1 in every 10 web requests you do go through some piece of CloudFlare infrastructure around the world. We're also the most connected network in the world. We have the most peering and interconnection points around the world. But today I'm here to talk about something that's a little bit more specific. I'm here to talk about our serverless platform and the kind of philosophy behind it. I'm not actually going to spend very much time talking about our platform. I'm going to talk about why our platform is fundamentally different than anything else that exists. And I'm going to try to make the case to you that this is how all of the other platforms are going to look in a few years. And so it would be great for you to use ours. But the truth is, I believe that if we are correct, you're going to have a lot more choices very soon. And so we're going to have to keep working really hard to convince you that ours is actually the best one. What I really want you to believe, though, is this philosophy is the right way to approach serverless and that it fixes a lot of problems and is fundamentally better. The story behind it starts a long time ago. For me, it starts 2 years ago when I joined CloudFlare. The first meeting I had was with a customer who was asking if they could essentially run A/B tests at our edge around the world. They didn't want the latency of going back and forth to an origin. They wanted to be able to run these tests everywhere. And we looked at their needs, and we talked about it, and we thought about it, and we told them no. We have no ability to let you run your own custom code on this edge around the world. If you give us a process, we would have to run it on thousands of machines. It would be very expensive. There's no way to secure it. And whatever we build would have to be incredibly custom for you. And we have 100 other people who are asking for this, and we cannot spend that amount of time on it. We can't give you a platform because there just is no way to isolate a process in a cheap enough way and an easy enough way that we can run it at thousands of machines. We have 10 million websites. If we did it for 1 in 100 of them, that would be running 100,000 processes on each of our edge machines. It's insane. It doesn't work. We can't do it. Luckily, there are people at CloudFlare who are smarter than me. And they continued thinking about it. And they ended up building something that works a little bit differently than the other serverless platforms, something that allowed us about 3 months ago to come back to this customer and tell them, yes, you now have the ability to do this. This is something that is now technologically possible that was not possible before. And so what I'm going to talk to you about today is what that thing is, what solved that problem for them and for us, and hopefully for you. I'm going to talk about what it is, I'm going to talk a little bit about how it works, and then I'm going to talk about what I think is the future, what the future might look like if this is correct. But first, we have to go into the past. This is a server circa 1990. It's the kind of thing that you would build a website on. And you would buy a few of these, and they would come in 3 or 4 months in a big, gateway box with cow print on the outside, if anyone remembers that. And you would install it, and for the, $20,000 expense, you'd have the ability to, have 100 or 1,000 customers. This was a system that scaled very slowly, and it required a lot of operations knowledge. You had to really know how to manage infrastructure and manage systems. It was a huge burden on everything you were building, right? Getting an early website online was 90% getting a website online and 10% whatever you were actually building. This is what would run on this server. This is the Linux Penguin. It's very cute. Around 1998 or so, there was an innovation called virtualization. And for the first time, it was possible to not run one thing on this big server that you have, but you could pretty easily run 3 or 4 or 8 or 10 isolated processes, isolated containers, isolated virtual machines. And so instead of having to buy 20 servers, you could buy 5 servers, which is a pretty nice improvement. It didn't shake up the world all that much until Amazon and AWS, which was 2006, maybe. And here we have a lot of our Linux Penguins carefully distributed into this, what we're presuming is an Amazon data center. They're probably not this pretty. And you now have the ability to rent by the hour server time. You still have to know a lot about operations to do this. You have to know how to run a Linux server. You have to know how to start a Linux server. You have to scale these things and know when to ask for more capacity, and that more capacity takes a minute or two for a server to start up. You have to know how to scale them down. You have to know how to apply security patches and do a whole bunch of work. You certainly can't just sit down and think you're going to write the code that your customers need and be done. But it's a huge improvement over waiting months for a server to arrive in the mail, and that's why AWS is such a powerful and successful thing in our world. And then they came out with Lambda. And this was a few years ago, and you probably have heard of it if you're at a serverless conference. Lambda is a pretty cool thing, right? It's a developer ergonomics layer on top of this system. It's the ability to sit down and write some JavaScript and click deploy, and it runs in a data center somewhere, and it will auto-scale up and auto-scale down. The interesting thing, though, is it doesn't really change how the code is actually running. Every serverless function that you can run on any platform that you might use today, unless you happen to use ours, has its own containerized process. So it really runs very similar to how you would have run a containerized process on any system in the past. It just scales for you. And you can tell that this is what's happening because you can actually run your own binaries in Lambda if you want. Right? That's how people ran Go and compiled executables for a long time. They would write a little JavaScript shim that would use the nice Lambda interface. And then it would just spin up some process that was also running as a child of this container. So the universe didn't really change. It just became a little bit easier. And that's pretty nice. Until you have to run a lot of these. When you have to run a lot of processes, you have to context switch a lot. And so that means that your processor has to go from running one process's code, and it has to take the time to swap all of the stack out and a bunch of memory out and run someone else's code. And then it gets to run it a little bit, and then it has to context switch again. And when you're on a machine that does 3 or 5 or 7 things, that's not a huge deal. But if you want to be able to run 100 or 1,000 of these functions on a machine, you end up spending a huge amount of your time just context switching. You have this huge tax on everything that you do because the tools that you're using were built for a world where you'd only be running a few of them. And now, all of a sudden, you want to run hundreds or thousands on these machines because we all want microservices and we all want to be able to write 1,000 lines of code and call that a service. And so this context switching, if you add it up to our kind of use case, something like 100,000 requests per second, and context switches are about 10 microseconds, which is a pretty charitable number, you end up spending the entire CPU time just context switching. So this is one of the reasons that traditional para-virtualization containers didn't work for us in that original example, because the minute we hit a reasonable number of requests per second coming into different customers, because we have 10 million different customers, you're going to run out of CPU time just switching between them. So that's a problem. That's kind of a waste. There's also this API, and this is the best picture for it that I could find online. I like it a lot, called POSIX, which is the standard API that all processes implement. And every one of these virtualization systems that I talked about, their crowning glory is that they implement it. You get this API if you run your own metal, your own hardware. You get this API if you run a VM. You get this API if you write a Lambda. The problem is, this API was designed in 1965, 1972. And it doesn't always work great in the situations that we're talking about. You spend a huge amount of your time handling interrupts to go from user space to kernel space. And you spend a huge amount of your time doing security checks. And you end up wasting somewhere between 25 and 33% of the time that an IO-bound process uses just interacting with the kernel and trading back and forth into different spaces and getting different permissions and resources. It's a huge tax on everything that we do. And it is somewhat intrinsically necessary if you want to provide this API that we all love because it lets us run the binaries that we understand. There's also another problem. And I'm going to call this a problem because I think 33% of my CPU's time spent not running my code is a problem, even if it seemed like a necessary evil. Cold starts. Node was not designed to start quickly. Node was designed for you to spin it up on a machine somewhere, and you could wait half a second or a second, because you'd only do this occasionally, and it would run some code for you. Even running it interactively, it takes half a second for it to start executing your code and for you to interact with it. It's not a big deal. Until the way you start that node is with a request coming in, which is what Lambda does, right? Lambda, you run your request through API Gateway, and it gets to the machine, and it needs to start a new Lambda up just to respond to that initial request. And that means that first request takes half a second. If you're using VPCs, it can take up to 10 seconds. So that's a big problem. And each time it needs to spin up a new Lambda, you have to do another cold start. The fundamental reason for this is because these runtimes, whether it's Node or the JVM, were not meant to run in multi-tenant environments. They were meant for you to spin it up and leave it running for a long time. So they're not designed to start quickly. They've worked a lot on getting this down, and you can track over time how cold start might have gone from half a second to 400 milliseconds. And some people can get it down to 200 milliseconds. But it's a lot of very hard work because you're working with tools that no one ever realized were going to need to be able to start executing new code incredibly fast. And again, that 200 milliseconds or 500 milliseconds is the CPU churning on something that is not my code. It's something else. So what we end up with is a really good way of writing code, which is functions as a service, serverless, the thing that we are all here to talk about, and the thing that we hopefully know and love, built on top of 40-year-old tools that I think are not appropriate for it, that do not bring it out in its best light, that waste a lot of CPU and waste a lot of memory, take way too long to start, and all of those things are fundamentally unnecessary. So let's start over. Let's figure out a different way of providing all of the things that we want without being built on top of that foundation. So what are those things that we want? We want to be able to run code from a lot of different developers, or from all the developers in your company, or all the different pieces of code that you want to write. And we want to be able to run all of those things in an isolated, safe, trusted way. We want to only use the memory that our code actually consumes, which seems like a very simple thing, but in practice, an empty Lambda node consumes about 35 megabytes of memory, even if I have 3 lines of code. So somewhere I'm going from 200 bytes of code to 35 million bytes of RAM consumed. So let's get rid of that. And we want to spend all the CPU time on our actual code, which means I don't want the CPU wasting a bunch of time spinning up new virtual machines. I don't want the code wasting a bunch of time doing security checks and traveling in between kernel space and user space when it doesn't have to. And I don't want the CPU wasting time context switching if it doesn't have to. I want the CPU running my actual code. And then finally, this last one, it's pretty hard to scale anything across multiple regions, right? All of these cloud providers are divided into regions around the world and availability zones. And going from 1 to 2 is a lot of work. And very few people ever bother going above that, right? No one I know runs in more than 5 or 10. It's a lot of work. These systems, again, were designed for you to be renting a server by the hour that you were going to keep running for a month. And we've built on top of them some very nice developer-friendly ergonomics that are great, but are still constrained by that model. And there's no reason that we have to worry about, as developers, which region our code is running in, unless you have very valid compliance reasons. So now we take a look at something else. This is the tab list from my browser as I was working on this. I was listening to something in Spotify, I guess. The browser actually does a lot of these things really well. The browser runs untrusted code from a whole bunch of different people. It can start running new code super quickly because it has to every time you load a website. It has to consume minimal memory overhead because every time you have to kill Chrome or Firefox, people get pissed off. It kind of does all of these things that we are looking for our ideal, beautiful platform to do already. So what if we took the V8 from the browser and we ran it on a server? And that doesn't mean we're going to run Node, because Node is a layer built on top of V8, which is, by the way, the JavaScript and WebAssembly engine that's in Google Chrome. We don't have to use Node, because again, Node was meant to be started up once and left running. It has a bunch of, it's meant to live in a world where we have access to file systems and things like that. What if we just used V8 itself? And we used all these concepts that it has to run code in different tabs and from different domains to run code from different developers. We do it on the server. Turns out, Kenton had a really good idea. So this is kind of a model of what we're talking about. In the previous world, you would have a process, or a virtual machine, a containerized process, whichever. And it has a bunch of overhead. And then in the corner, you have your actual code. And it's very unlikely that, if your Node Lambda starts up with 35 megabytes of memory just to run Node, your code is a megabyte or something, right? Maybe it's consuming a little bit more, depending on what it's doing. But basically, you're mostly just paying Amazon to run Node for you. What if we ran one VM with one overhead, And then we just filled it with everyone's code, separated and secured, instead of by using processes, with something else, some other little container that you can run code in inside a single process that we call an isolate, because V8 calls it an isolate. So instead of you getting a containerized process to run your code, you get an isolate to run your code. It seems equivalent or similar in nature, but isolates are much lighter weight. They can all share the same virtual machine. They have much lower overhead, and they can start almost instantly. So we have no VMs, we have no containers, we have the ability to run millions of functions. And here are some actual numbers that talk about what you get when you do this. You get 3 times more compute per dollar. I don't know what Amazon's margins are. I don't know if that's because they are charging too much, or if it's because this is actually much more efficient. I think it's certainly at least 25 to 33% more efficient, just getting rid of a bunch of the operating system stuff. But in our tests, you get 3 times more compute per dollar. You know, if I run a really compute-heavy thing, it completes in a third the time. And on all these systems, time translates to how much you get charged, which also means it's 3 times faster, which is another way of saying the same thing, but also cool. It uses 10 times less memory. An isolate consumes about 3 megabytes of memory. And again, one of these node lambdas is about 35 megabytes. And the cold start time goes down by 100 times. And this is giving Lambda a lot of credit and saying it only takes 500 milliseconds. It's often much longer than that. When your function can start in 5 milliseconds, everything changes. Because 5 milliseconds is less time than it takes for a packet to get from here to, Paris. So you don't notice one of these things starting up. You can start them up whenever you want. You can start them up in response to a request. You can, if you deploy some large web service that gets 1 million requests per second, you can just deploy it. And if it needs to spin up 100 or 1,000 of these to meet the demand, it can do it effectively instantly. The concept of starting your code becomes entirely meaningless and disappears. The concept of scaling disappears. Auto-scaling disappears. You don't have to worry about how many copies of something are running. You don't have to warm up anything. You don't have to, there's no set of requests that run slower because you don't have enough scale yet. All of these concepts disappear. It is no longer a problem that human developers have to deal with. You also, this is a very washed out map, but if you study it very carefully, you can kind of tell it's a globe. It's a Cartesian projection of a globe. These are CloudFlare points of presence. You also get the ability to run code wherever you want, because if I can start your code instantly and I can stop it just as fast, it really doesn't matter where I run it. I'm going to have to process one request. So I can process that request in Djibouti, or I can process that request in Madagascar. It doesn't matter. So I can effectively just run it everywhere. And if you get a lot of requests everywhere, I'll keep it running. And if you get you don't get a lot from half the world, I don't run it there, and you'll never know the difference. But to your users, your code is running everywhere on Earth within 10 milliseconds of them, no matter where they are. That's really cool. And you get that because starting the code is now free. We have freed ourselves of this model where you're renting someone's server. And instead, you're legitimately paying for someone to process a request for you. You're paying them less, which is also cool. So the concept of regions and availability zones is also gone. We don't have to think about it anymore. Everything can be deployed everywhere. It'll just run wherever your users are. You don't have to think about it. You don't need to do operations. You don't need SREs. You don't need to know how to manage the cold start time of Lambda and how to poll them with CloudWatch metrics to keep it running. You can just write code and click deploy. And just like it runs in a browser, it can run on a server. It's really cool. And so the next kind of question is that sounds like a cool idea, but is this theoretical? Or is this something you guys are planning on building? So this is a tweet from Laurie Voss, who's the COO of NPM. And just by show of hands, who has used a node package in the last 30 days, or NPM? Okay, you have used CloudFlare Workers already. Congratulations. NPM is built since May on workers. Every time you download a package, it is running a worker, hundreds and hundreds of thousands of times per second. A worker executes on their behalf, along with that of many other customers, obviously. So if you use NPM or you use Node, you already use workers. And it already processes many hundreds of thousands of requests per second around the world. It is a real, actual technology that exists right now, and they use because they have all really wanted to be able to make their service fast. People don't like it when NPM is slow, and they have users all around the world. And so getting that code running, getting the code that decides, do you have permissions to a certain package, for example, Is this thing cached? Or if the original origin is down, let's go to some other origin. All of that code, getting it close to their users makes everything way faster for them. So now they get to just write JavaScript and click deploy, and it runs everywhere instantly. And so they do that, and they like it. This is another way of looking at performance. This is me running a really CPU-intensive thing on Lambda at Edge, and Workers, which is our platform, which is an isolate-based platform that we're talking about today. And this is showing what percentage of requests were below a certain latency. So 50% of requests were about maybe 20 milliseconds for Workers, and 200 milliseconds for Lambda at Edge, and 400 milliseconds for Lambda. So it's really, really fast. And it's actually 3 times faster even when you forget the fact that it's distributed around the world. So if I run this test, which using a tool called Catchpoint, if I run the test in Virginia, and I have my Lambda deployed in US East 1, which is near Virginia, meaning it's not about the globe, it's not about how distributed this thing is, it's not a CDN thing, Workers are 3 times faster. Why is that? Maybe it's because Amazon decided how fast the virtual CPU should be in 2006, and that's what they give you. Maybe it's because it's just intrinsically expensive for them to offer the service. I don't know. But it's pretty cool. And it runs everywhere. So that's kind of the introduction into what this thing is. What happens if the process in the isolate hangs? Hang can mean a few different things. If it fails in any way, it can just be trivially and instantly restarted, right? Because it doesn't take any time to restart it. If it literally hangs like it's infinite looping, it'll get killed when it hits the limit of the amount of CPU time that it's able to use. V8 kind of already implements all of the controls that you get from your operating system right now. So it implements the ability to limit the amount of memory and limit the amount of CPU, the ability to not obviously read other people's variables and give strong isolation. And we rely on that isolation every time we load PayPal.com and load Spotify.com in 2 different tabs, right? There has to be code that prevents Spotify from reading my variables in PayPal. And that's the isolate separation that's already built into V8. So it already has a lot of this capability from its use in browsers. Obviously, having your code deployed in 155 places or more places than 3 is amazing for reliability. Because each of these places are effectively their own availability zone. Right? They're able to run independently even if the network is partitioned or cut off in some way. So you really have this idea that I have my code running in 155 places. If one of them goes offline, BGP is just going to route the traffic to other ones. And it's as if it never happened. It's an entirely new way of thinking about reliability of services. It's amazing. Tell us about practical limitations. So there are 2 answers to this, right? There's what you can do with Workers today. If you go to cloudflareworkers.com, which you should do, cloudflareworkers.com, cloudflareworkers.com. And then there's what are the intrinsic limitations of isolate computing as a concept. So to the former, tons of stuff, right? We're super early right now. We just launched this thing. We have so much to build around storage. We have so much to build. You only can make HTTP requests right now. We don't have the ability to make TCP and UDP requests directly. We have so much to build around connecting Workers together and creating queues and doing data processing and importing data and exporting data and monitoring and metrics and debugging, and there's a ton for us to do. And if you want to work at Cloudflare, you should, and talk to me. But none of those are limitations of isolates, right? We can implement all of that stuff given time. The limitation of isolates is you can't run compiled binary code. If you have a process that already exists, unless someone wants to write an x86 emulator in JavaScript, feel free. You can take that idea. There's no way to run an already compiled binary. You have to have access to the code or the ability to compile it into WebAssembly, or it has to be in JavaScript. Like one of these has to be true. So that's the if I'm talking to some giant mega corporation that has a ton of legacy code, it's a very similar pattern to people talking to them about serverless at all, which is you're going to have to rewrite stuff, and you're going to have to rethink stuff in order to get it into this model, to some extent. Maybe you can use the same libraries. Maybe you have new libraries and better libraries. But obviously, it's much easier to convince someone to build something new on a new technology than it is to support all the old stuff that already exists. And so people aren't going to stop running processes anytime soon. But that doesn't mean we have to suffer on their behalf. We can we can reap all the benefits. So I mentioned WebAssembly. V8 is a JavaScript engine that's in Chrome that this is all built on, right? It isn't just a JavaScript engine, though. There is a team of people at Google, who are very nice, who work on adding WebAssembly support to it. And WebAssembly is this ability to have a single assembly language that every compiled programming language can be brought into, and then it can be run in browsers. At least that was the idea. Turns out you can also now run it on servers as a part of Workers. So that means Workers is not something that's just for JavaScript. It's something for Rust. You can write Go. You can use some library you have that's written in C++, that really cool machine learning thing. It all works. Even cooler part is you can intermingle these things. So you could install some really cool NPM dependency that does machine learning in Rust and just use it in your TypeScript code that also brings in some Go dependency. And because the web now has this single assembly language that can be run on this thing, all of those things can intermingle. And we don't have to care about what language things are written in anymore. You can just, everything just becomes a library that's available to you. And you can choose to use whatever language makes you happy. And it can all run on this system with all of the wonderful performance and starting and features that we talked about. So it's really cool, and I really, really think this is what the future is going to look like. Another thing, and this is one of Kenton's slides, is the idea that when you have the ability to trivially start these things up, you can do some other really cool stuff. For example, let's say you make a request to api.twilio.com, and it is implemented as a worker. It makes a request to api.stripe.com, and it is implemented as a worker. Well, we can just run them on the same machine, in the same process. So instead of that request having to go through the network to some other region or some other availability zone or even to another machine in the same rack, all of these things can run isolated in their own isolates, so totally securely, but in the exact same process. So we can go from running Twilio's code that no one else has access to, no one can see, to running Stripe's code that no one has access to, no one can see, without even entering kernel space. We can make it so that you can compose these services together with no overhead whatsoever. You can consume APIs and use things that other people build and use services that other people make and resize your images and do all these things. And it can all run on the same machine in the same process because it can be started and stopped instantly. That's really cool. That's not a thing you can do now. It would be very hard for me to convince Stripe to install Stripe on my server. But everything becomes not just like on-prem for you, but everything becomes effectively the same as if you wrote the code. And this works if you're calling something that your coworker built. You can use the web, you can use an HTTP request, and call some service that has a REST API or a GraphQL API that your coworker created, and by the way, it will happen to run in the same process and never actually go over the wire, because it doesn't need to. That's really cool. CDNs are over. The concept of a CDN is totally meaningless, because CDNs were all about, we have static files. And by the way, this is a very controversial thing for me to say, because I work at CloudFlare, and we're the biggest CDN, right, by number of customers. There is no purpose to static files and serving them one way, and then I'll serve the dynamic parts of my site some other way. It doesn't make any sense. You can just make it all dynamic, and it will all run exactly where your CDN was running before, right? The purpose of my CDN was, I had static files, and I'm going to cache them in these 155 places around the world to make certain stuff fast, and then everything else has to run in, US West 2. But when I can run everything everywhere, I don't need that anymore. I don't need to separate my resources. I can just render pages however I want. I can run preact, or I can compile stuff on the fly, or I can compile and I can cache it. I can do literally anything that I want, and the idea of static files as a concept is just meaningless, unnecessary. I don't have to think about, the only purpose of caching headers is for the client. That's pretty cool. And finally, this doesn't seem like a controversial statement at first, but then you look at these scare quotes and you're like, what does he mean? Entire applications are run on the internet, right? Right now, applications run on servers, and then the data transfers over the internet. But when we have, 100 whatever data centers around the world, and then when we have 1,000 whatever, and then when maybe we have 10,000 someday, and maybe they're in every cell tower, your application fundamentally is just going to be kind of running on the internet. You won't know where the code is running. You don't need to know. You as a developer will sit down, you'll write code, that hopefully the only code you have to write is the code that actually builds the thing you care about. And then you just click run, and you don't have to care where it runs. So it's as if Your application lives on the fabric of the internet itself. That there are no fixed locations or regions or availability zones or points of presence or any of these things that you have to care about. And that is what the future hopefully will look like, where all code runs close to every user consuming it in the optimal location, and nobody needs to know the operational details that are required to make something multi-region or anything like that. That's pretty cool. So this is my tagline for the talk. Just write code. Just sit down and write the code that you want to write. I mean, we have a lot of conversations with people who are skeptical of this or don't fully understand this, including inside the company, because one of the things we are doing at CloudFlare is rewriting all of CloudFlare to be workers, because it turns out it's way easier than managing, binary deployments out to this network. And even developers at CloudFlare don't fully understand it at first all the time. And then they sit down and they start writing these things and they click deploy, and then they realize I can deploy a piece of code and it will, it's getting 200,000 requests per second. That's not anything that I didn't have to talk to an SRE in order to do that. I didn't have to let anyone know. That's really cool, right? That's incredibly powerful. So the biggest piece of advice that I have to people is go to developers.cloudflare.com or go to cloudflareworkers.com and try it. Like, sit down and write a worker that does anything, that makes a website or whatever. And you will have a good time. It will be a good experience. You'll go like, this was bizarrely and oddly easy, and I didn't believe him in the talk, but it was. It's a real product. It actually exists. And then finally, my final pitch. Tonight, we have 2 more talks about this at our London office at 6 p.m. You can come to that as well if this was fascinating, or if you find me so insufferable that you would like to hear other perspectives on the matter.